Go ahead and actually, before let me start recording this session here.
I started it.
Oh, thank you,
Go
Stacy.
for it.
Perfect. So what we're going to be going over today is some hands-on exercises involving Sumo Logic. In previous sessions that we've done for the certification, we have some slide decks, we do some demonstrations. But for today, I think we're just going to go straight into the labs. I think it's going to give the best opportunity for you to get your hands dirty and get a feeling for how Sumo Logic works and how you can start to create queries. So we're going to go ahead and log into this, well, the website you should be familiar with. It's going to be service.sumologic.com. And then we'll go ahead and use these credentials. So if you want to go ahead right now and start to log in, the username will be training+labs@sumologic.com. And the password will be Sumo Labs, capital SUM0, capital LABS, exclamation point. And I'll give everybody a few moments to log in. If you have any questions during today's session, go ahead and post them either in the chat or the Q&A. And I have my team member, Stacy, on the line here, and she'll assist with answering any questions. So as mentioned, we're also recording today's session, so we'll send that out to you later. So I'll give everybody a few moments to log in. I'll also let me put those let me put those credentials in the chat window as well. And so once again, it's just going to be service.sumologic.com for the URL. The username will be training+labs@sumologic.com. And then the password will be Sumo Labs, capital SUM0, capital SUM0, capital LABS, exclamation point. And then once you're in, log in, we're going to go into the certification section and into the labs for level 2. So I'll do that in a moment. Just give everybody another second or two to join us. And the training environment that you're going to have access to, you may have used before. We use these credentials in some of the other classes we have, but it's going to provide you an opportunity to go into a live Sumo Logic account, if you will, and start to mess around, for lack of a better phrase. So we have a bunch of different lab data in there, a bunch of different sources of data. So if you want to take a look and see, look at Apache logs, look at some O365 logs, look at CloudTrail logs and see how they work before they're even in your environment, this would be a good test bed to go ahead and do that. So I'm going to assume everybody's logged in by now. And if not, like I said, just go ahead and send a message in the chat and Stacy will help you out. But once you're logged in, you should be on a screen that looks very similar to this, which is the home page. And so what we'll do is we'll go to the certification. And we'll go down to level 2 Sumo Power User, which is what we're doing today, and click on the hands-on labs right here. When you do, that should open up another set of labs, or another tab, excuse me, which has a set of labs in there. And then we'll start to go through those. So just as you redo those steps, you're going to log into home. You'll go to certification. You'll go to level 2 Sumo Power User and go to hands-on labs, click it, and then you'll have another tab which will have the labs in it. Cool. So let's go ahead and start with the first lab first. Seems like a good place to start. Now, today we're going to go through these labs. Like I said, over the next about 2 hours, we'll do the labs, and then we'll have an hour set aside for the certification exam. And the labs we'll do, we won't do all of them just due to time. So we will skip some of the labs due to just we only have so much time together. And so any labs you do skip, I don't want to have you think that these labs are not important. They certainly are, just due to time constraints. We don't have a chance to go through them. Also, we have about, let's see, about 20 or so, even a few more than that, probably 22 labs or so. Some of them have kind of subsections, subparts, and we may just skip around just once again based on time. But we'll still get a very good feel for what the system can do and a lot of query language that you'll be able to utilize and take advantage of. So let's start with lab 1. So, and the way we'll do these, I should have mentioned as well, is you'll certainly do them at your device. I'll do them on my screen. For some of them, I'll go ahead and give you a few moments to kind of jump ahead, or not jump ahead, but to start doing the lab and give you a few minutes of leeway time to figure them out. For other of them, I might just dive in. But as I'm going through them on my screen, I'll certainly explain why we're doing this lab, what we're trying to show you. So we're going to start here with search basics, metadata, and keywords. It's a great place to start. This may seem very basic, and as it should, it's the first lab. So let's get rolling here with just lab 1-1. So for this one, we want to search for all messages with the source category labs Apache Access for the last 15 minutes. So what does that mean exactly? Well, we need to search for this set of data for this period of time. So to do so, we're going to go into our Sumo session. We're going to want to start a new log search. We can do it two ways. We can go to the home screen and click on the log search button, or we can go to the top of the screen in that bar, go to the blue button that says new, and then go to log search. Same difference, however you prefer to get there. But ultimately, you should have a screen that then appears like this, which will have the ability to start to enter your queries. So for this very first query, we wanted to search for that specific source category. So all we do is just paste that query in or type it in, depending on kind of how lazy you're feeling right now. When you do type it in though, and I should type this first one in, the search ahead is going to start to help you. So as I start to type source category, it's going to help me identify what I'm trying to enter. And then same thing as I enter the actual source categories themselves, the search ahead will help me locate the source category that I am typing in and save me a couple of keystrokes. The system is also going to use the last 15 minutes as the default time, and that's why we're going to search for the last 15 minutes of data with this lab, just so we're going to use the default. So doing a very basic query here, just entering the source category, using the default time, clicking start, and then getting our results here. Now, your results may differ a little bit from mine. It's really going to be based on the time period that you're utilizing. So when I click start, my 15-minute window is such. You might click start 3 seconds later, your 15-minute window is now a little bit different. And that's why your results might not exactly match. And that's perfectly fine for today. So we now have a query. We now have results. We've kind of done step one. Now let's go ahead and let's do 1-2. So we're going to identify client errors here. So what we want to do is using the syntax of 404, we want to look for client errors. And we want to use that 404 as a string here in the query. Oops. Sorry about that. So if I go ahead and type 404 like I did, the system is going to look through the Lab Apache Access data and look for the string of 404. And so if I click start, I will now see in my results those log messages that have a 404, and I'll have that actual text or string of text for 404 highlighted. So 404, 404, et cetera, et cetera. Now in this query, I did not put the end the lab wants you to, and I left it out intentionally to show you that you can leave it out. So the system is going to assume that there is an end here. So putting access end to 404 or just leaving 404 on its own is the same thing to the system. The other thing I should point out with this lab is we were trying to look for client errors and looking for 404s to identify client errors. Now, in this case, we're simply looking for just a string of 404. We're not necessarily saying look for status codes that are equal to 404. Now, we will get there, but I just want to mention that in this case, we're just looking for that string. We're not necessarily looking just for 404s in the status code. So subtle difference, but I just want to point it out. Lab 1-3 is going to have us look or utilize Boolean logic when searching. So I'm going to take this query. And so what we're going to do with this query is we're going to look for log lines that match a couple different strings of text, as well as take advantage of the wildcard to look for strings of text that start with the word check. So we're trying to look for those lines that have the word error or check or check out or anything that starts with a check within the Apache Access data. And so the way we're going to specify that is exactly like I did. So we're saying here, look at the Lab Apache Access data and look for the word error, or specifically the string error, not necessarily the word, the string error, or check, and anything that starts with check. So this would include check, check out, check in, check up, anything that starts with that phrase. So now when I click start, the system's going to do what I tell it to. And now it's going to highlight those words that have check, or if it had error, in this case, we just see a bunch of checkouts in here. And so the system has done what we've told it to. And there's just about 900 results that have the word checkout in them of our Apache Access data. Okay. Then this next query, and actually I'll just stay on the screen for a little while. So with this next query, we want to go ahead and look at a different set of data. So we want to look specifically at lab Apache error data. And we're doing this for two reasons. One, to look at a different set of data, and we'll actually look at this and the other set of data, the Apache access, in a few moments. So that's one reason why we're doing this lab. The other reason is that we want to look for the last 45 minutes worth of data. And so as a reminder, time is selectable within Sumo Logic, and there's a couple different ways to locate it. There's the relative time periods that we've already defined, where we said these are commonly used, last 15 minutes, last 60 minutes, last 3 hours, etc. Or you could use the syntax, as you can see right here, and it's shown in the lab, of minus 45M. So if I want to look for the last 45 minutes worth of data, just do minus 45M. And now when I click start, I should get roughly 4,300 messages or so. Now within the results of these log messages, you may have noticed that the word error is highlighted, or actually it's red text, not actually highlighted, but the text is red for error. And that's not because you're looking at a source category that has the string error in it, although that certainly be a good guess as to why it's showing up. The reason is we've simply gone ahead and for certain keywords, error or exception are the ones that come to mind. We've gone ahead and put them in a color so that as you're going through them, your eye is kind of naturally drawn to them. And so you might, if you're looking through a large set of data and you see a bunch of errors in red, it's kind of drawing your eye versus just the regular black text. So that's why we've done that. Okay, now in this next lab, this is going to be 1-5. Now we're going to look across two different sets of data at the same time. So let's say we want to search across labs Apache error access, lab Apache error data and lab Apache access data. How do we do so? Well, we can define multiple source categories in the same query. So we can say we want to look for source category, labs Apache access. Now, if I was to run this as is, I'm going to run into a problem because remember, there's the assumed or implied end here. And what this is saying to the system is show me data that resides in lab Apache error and it resides in lab Apache access at the same time, which is not possible. So if I run this like that without putting anything in between them, I get no results. That's why we want to use the or here, because what we're saying is look for data that resides in this source category or this source category. And now when I run this, I should get a lot of results, roughly 170,000 of them. Now with lab 1-6, we want to show another way to write this using wildcards, because you could express this by getting rid of a whole bunch of the text and just doing labs Apache star. And by doing so, you're saying, show me lab Apache access data, show me lab Apache error data, and then theoretically anything else that would reside in that kind of a component or folder structure of lab Apache, whatever, would be displayed. So showing the idea that you can either explicitly call out the source categories you want to utilize, or what's recommended, use the wildcards where you can, just saves you time, which is always good. All right, let's go ahead. Lab 1-7, we can do, but it's to be perfectly frank, it's going to be a little bit of a race to see who could do it first. The reason being, I jokingly say it, but it's true, there's a limit of concurrent sessions that can run a live tail. So I'm actually going to see if you guys beat me to it, which you probably did, but let's see if I can demonstrate it anyhow. Because what this feature is going to allow you to do with live tail is it's going to allow you to view live data as it becomes ingested into the system. So what I did here, and I did it a little bit quick, just I wanted to kind of rush and beat you guys. So let me take a step back. So here I'm saying, show me lab Apache access data for the last 15 minutes, last 30 minutes, last 45 minutes, whatever, the previous period of time, which is certainly very valuable to do so. But what if I want to look at data as it starts to become ingested into Sumo Logic? That's where LiveTail helps me. It's like a LiveTail, a tail-f function in a Linux Unix environment. It's going to provide you, though, that view into that data as it gets ingested. So by clicking LiveTail, the system is taking that query and bringing it into this view. And now I'm seeing data as it becomes ingested into Sumo Logic or collected into Sumo Logic. And this is helpful for a couple of reasons. One is if you want to see what data is coming into Sumo Logic and in real time, this is how you would do it. The other place this is helpful is if you set up a collection and you're basically telling the system, hey, grab this data, bring it into Sumo Logic, and you want to confirm that that data is being ingested, this is how you can do so as well, because you're seeing in real time that ingestion take place. So Livetail is helpful in some use cases. For many users, they never go near it. So I'd want to point it out, show it to you. At least now you're aware of it. So cool. So let's go ahead and start with section 2, or lab 2. So lab 2 is going to introduce simple parsing, grouping, and filtering. So just a little more advanced, but now we're going to start to get some parsing involved in here. So with the very first lab, and actually, I think I'll give you guys a few moments to do these labs. So why don't you go ahead and start with lab 2-1 and continue on to lab, do it through lab 2-3. So I'll give everybody a few moments, and then I'll pick up and talk about what we're doing and why we did it. Okay, so let me start with the first portion. And so the first portion, we're taking lab Apache star, which is indicating that we want to look at lab Apache access as well as lab Apache error logs for the last 15 minutes. So that's pretty similar to the query we just did previously. But now we're going to introduce the count operator, because what we want to do with this first lab is count the results by source. So very straightforward. We're going to do a shift enter to do a new line. We're going to do a pipe as a new line as well. So we use the pipe character to designate a new line. And then what do we want to do? We want to count by source. So the syntax for it rather is pretty straightforward. Count by source. When we do this, when we click start, we're going to be getting a new section or tab within the results. So originally we were getting our results that showed the messages, which showed the raw log messages. Now, since we're using a count operator, which is a mathematical operator, we get a new tab for aggregates, which is going to show the results of that math. And so what we see here is over the last 15 minutes, there have been 56,000 messages associated with the Apache access source of data and 1,400 associated with the Apache error. Now, we're going to take a step back in lab 2-2. And so I'm going to get rid of this query. And what we want to do is we want to start to parse per regex. Now, as a reminder, if you're new to this, let's go through parsing real quickly, because it's important to understand what it does and how it helps you in Sumo Logic. So if you've heard this little pitch before, I apologize, but it'd still be helpful. So essentially, in these log messages, we have valuable information. Hopefully, I'm not telling you anything new with that, of course, but you can see that information in here. So here, for example, we have time information. Here we have a client with an IP. So there's information in these log messages that may be useful. Let's see, here's some others. Here's a status code. We'll play with status codes a little bit. If you joined us before, you're probably familiar with them. What they tell us, though, is information about when you go to a website. Did you get there successfully or not? You've probably come across a 404 status code at some point. So the idea is that sometimes there is valuable information in here, and we want to start to extract that information. And we need to tell the system how to locate that information. So like I mentioned, here's an IP address. Oh, there's an IP address. So we need to tell the system how to locate it. And so we can use regex to do so. Regex is a stands for regular expressions. It's a pattern matching system, not specific to Sumo Logic, but what it tells the system is look through this set of text, and when you have this pattern or find this pattern, assign this field to it. So that's what this second line is doing within the query. We're saying we want to parse, we want to create complex data to create field labels. So essentially we want to create a field label. How do we want to create the field label? We want to utilize regex to do so. What is the field label we want to create? It's called IP_address. And the way the system is going to find an IP_address is to look for this syntax. Look for number.number.number.number, or more specifically, even look for digit with 1 to 3 characters, dot digit with 1 to 3 characters, et cetera, et cetera. So now when I run this query as is, I should now get a field for IP addresses, and I should get those IP addresses extracted out. And so now I do. So here was the original log message. It found the IP address, and then it displays that IP address for me. Now I can go ahead, and now that I have a field called IP address, now I can count those IP addresses in the same way that I just counted by source. So instead of counting by source, I'm just going to do count by IP address, because the system knows what an IP address is, it knows how to locate it, it knows the values for an IP address, and now it can count all of them up. And now that we're doing count, we're going to get the aggregates tab, and now we see there were 1,800 IP address for 1,800 count for this IP address, 3,000 for this IP address, so on and so forth. Now the next portion of this lab is to filter out those with a count less than 2,500. So what we can do is this count ranges from 95 to 6,800 or so. But what if we only want to filter out a subset of those results? We only want to look at a certain count. We can very clearly just say, show us where the count is less than 2,500. Or if you want to turn that caret around, greater than 2,500. And so now when you click start, the system's going to look at the count of all those IP addresses and then only show those that are less than 2,500. So it's a way to filter out your results. The next part of this lab, which you may have done, but if not, is to display the results in a pie chart. The idea behind this is that by default, your data will be put in this tabular or table view, but there may be another way to view the data that you prefer. So while this table might be helpful, maybe you prefer more of a graphical way of viewing this. Maybe this bar chart really speaks to you. Maybe this line chart is going to be the best way. In this case, we're indicating to use the pie chart, or actually more of a donut chart here, depending on your favorite snack item, donut or pie. And so it's just a better way to, or maybe a better way to express the data, and that's what we want to illustrate with that portion of the lab. Now, the next portion of the lab is going to be section 4, and I'll give everybody a moment to jump ahead. Yeah, actually, why don't you guys go ahead and start this if you haven't, and I'll just pause for a moment and then dive into it. And the goal here of this lab is to create a query that is going to identify the top 10 source IP addresses by bandwidth usage. As it says in the lab, this will require parsing the byte sizes as well as the source IP. And what that's telling you is that essentially we're going to use 2 different parsing mechanisms in the same query, which is important that you know that you can do so, because it's certainly helpful in the right place. Now with this lab, if we read the kind of the goal of the lab, we can kind of look at it almost as a word problem, and it's telling us what we're going to need to figure out. So by telling us we want to look at the top 10 source IP addresses by bandwidth usage, this is letting us know, well, one, we need to tell the system how to locate a source IP address. We need to tell the system how to figure out bandwidth usage. Of those IP addresses, we need to tell the system just to grab the top 10. So if we look at it and kind of break it out in a word problem, it may help you not figure out the lab. The lab itself is here of how to do it, but it may help you understand the steps that are going through. But let's go through them one by one right now. So let me start a new query window and just go through each one. So first, we're going to look at that same source category, Labs Apache Access. We will be using that a lot today, so you'll hear it a few more times. The second portion of the query is we want to go ahead and tell the system how to locate those IP addresses. So we're going to do so in this case using the regex once again. So we're saying look for number. When you find it, call that an IP address. And I'm going to click the start button now rather than entering all the lines of the query. And I find this is just kind of a useful tip of when you're starting to create your query, rather than creating the entire query and clicking start and seeing, let me see the results, do start after each line to make sure that you enter things properly, you're getting the results you expect, you don't have any typos. Because what I've seen is often times somebody might write a 10-line query, for example. They click start, it doesn't work. Now they have to go and figure out where things went wrong. Was it line 7? Was it line 8? And go back and actually spend more time troubleshooting, where this way, run a line, do you get what you expect? Cool. Run the next line, is it about what you expect? Good, and so on and so forth. So I ran that second line just to verify that I'm getting my IP addresses, and I am. Now with this third line, we're going to go ahead and parse out the sizes. And the size is located right here in the log message. So I had mentioned this is the status code. This next 4-digit number is the size. So essentially when you go to a website, how much data is being transferred back and forth, that's what the size is referring to. So here we're going to use a different format for identifying the size. Rather than using regex, we're going to use what we call a parse anchor. And what we're doing here is we're telling the system to look for this string of text and then look for another string of text that will be near it and call that a size. So we're telling the system, look for a space, look for a 200, look for another space, whatever's after that, that will be the size. So now when I click start, let me confirm that the system is doing what I told it to. And it is, because now I have a column for sizes, and now I have a value for sizes, and the value for sizes matches the value that's in the log message. So now I have both pieces. So now I have my IP address and my size. But with this lab, we need to look at the top 10 source IP addresses by bandwidth usage. So what I need to do is take all those sizes and add them all up. And so that's what this next line is doing. We're going to take the sum of the sizes. So we're going to take all the sizes, add them all up, and we're going to call the result total bytes. But we're going to do this by IP address. And so that's what this line is telling us. I'm going to click start again. Now I have a new tab because we're doing math. The count operator or the sum operator is math. And so now I have all my IP addresses and the total sizes for each one. And there's 18 of them. Now the goal, remember, was to just do the top 10. So now I need to use the top operator. And as you can see here, as I type the top or type top, it shows me what this operator will do, limit number of sort of results to most or highest per group by function. So essentially what this will do, we'll take the list of IP addresses by total bytes, sort them, and then just keep the top 10. And that's exactly what it did here. All right, cool. If you have any questions about these labs while we're going through them, like I said earlier, just go ahead and post them in the chat. These are pretty straightforward, so I wouldn't expect too many questions, but we are monitoring them to see if anything pops up, so feel free to. Lab 3 we'll do together, and actually I'll explain why we're doing Lab 3. I'll show the source of data and then show what we're trying to pull or why we're doing the lab, because I think that will help rather than just doing the query itself. So we're going to look at some CloudTrail data first. So let me pull the data up, and I think you'll even see visually what we're trying to solve for. So I pulled CloudTrail data for the last 15 minutes. Now here's a CloudTrail log message. So here's an example of one. Now within this CloudTrail data, I have fields already defined. So for example, here is a source IP address field, and there's the value. Here's an AWS region and a value, event version and value, et cetera, et cetera. So within this set of data, I have these fields already defined. Now, what if I want to use these fields in my query? Now, I could go ahead and start to tell the system using regex to go ahead and extract these fields, looking for the pattern of starting with event source and just specifying this. It would be tricky, or not even that tricky, but I could do it that way. I could certainly use the parse anchor here, where I say, go ahead and look for event source colon, look for a space, look for the quotes, whatever's in the quote, that will be the event source. But what I can do is even easier. This file is in a JSON format, and I know that either because I know AWS CloudTrail data is, or just because it says up here, expand JSON. So this is kind of a clue, but this file is formatted in JSON. Since it's formatted in JSON, I can take advantage of the JSON operator and very simply type JSON auto. When I do so, the system is going to say, oh, here's all these fields. Let me go ahead and extract them for you and make them available for you. And now in my field browser, I have all these fields available, such as source IP address, AWS region, event version, et cetera, et cetera. So all these now are available fields. And now I can utilize these fields in my query. So that's what Labs 3-2 is going to have you do, is utilize the JSON operator into extracting those fields and then using that field name in your query in a count. So let's go ahead and do that. So let's say we want to now count by AWS region. This would be Lab 3-2. Very simply, since the system knows where an AWS region is, we can go ahead and do count by AWS region. And now, since we're doing count, we get results. And now we see over the last 15 minutes of our CloudTrail data, 857 counts belong to the US West-1 region and 54 belong to South America East. So JSON operator is really helpful, specifically if you're using JSON formatted files, then it's really helpful there. If you're not, of course, it doesn't really help. If you're ever given the option, though, of what format you'd like your log files to be in, this would certainly be one reason why you might want to utilize JSON, because you can then take advantage of those fields and the field extraction of them using just the operator. All right, cool. Let's go ahead and look at Lab 3-3. The 3-3, 4, 5, and 6 are all kind of related. So let's go ahead and this is one that I think I'm better off explaining rather than just having you go ahead and do. So let me show the set of data and show what the point of these labs are. So we're going to look at that Lab Apache error data again that we looked at earlier, just for a second. But this time we're going to look at it a little closer. And what I want to show in this set of data is the fact that some of these log messages have a client and an IP, and some of them don't. So here's the first log message. We have a client with an IP. The second log message in the exact same space, we don't. The next one we do. The next one we do. The next one we don't. So some of these messages have a client space IP address, some of them don't. That's what I want to show. Now, if I tell the system to parse out the client IP address, so using the syntax of, forgot my pipe, parse So if I do this where I'm telling the system to use that parse anchor of look for the bracket, look for the word client, look for a space, whatever's after that, we're going to call client IP. When I do that, the system's going to do exactly what I tell it. And if it finds a client IP, it's going to display the message to me. So here I have a client and an IP, and now I have a field for client IP, and I have the value of client IP here. Same thing with this log message, same thing with this message. The problem here is that I am not including those messages that did not have a client IP, because the system's trying to match the log message, and if it can, it will display the results. If it can't, it just leaves or drops that log message from the results. But what if I want to see those messages that didn't match? How do I do so? Very simply, I just add the option of no drop to the end of the line. And by doing so, the system will go ahead and look for a client IP. If it can find one, it will display it, like this line 2. If it can't, like in line 1, where there is no client IP, it will still display the log message, just there won't be a value for client IP because there is no IP to use as the value. So this is really helpful, this no drop option. It's not an operator, it's an option, because it's going to allow you to see, as you parse your data, what you're leaving out, what you're dropping. And then you will need to decide, should I drop that? If you're okay with dropping it and you didn't need that information, great, continue on and write in your query. If you are dropping that and you're realizing, hey, I do need this log message, then you may need to restructure your query in a way that includes that data. So no drop helpful for primarily for troubleshooting your queries, but there are some other spots that it can be helpful. Now I'm going to jump to Lab 3-6, and I just want to show the last line of it because it's going to kind of show almost an opposite feature, if you will. Because what we can do is we can say, show us the places that the client IP is blank, using is blank. So by running this line right here, what this is saying is show me only those places where the client IP is blank. And now when I run this, I'm going to get almost the opposite of what I got without the no drop. Where now I'm only seeing those client IPs that are blank. Anything that had a client IP doesn't display here because it wouldn't be blank. So isBlank is just another helpful, this would be an operator that may be helpful in troubleshooting or just helpful in displaying data that doesn't have, fields that don't have data, I guess would be the best way to say it. All right, cool. 3-7. So with 3-7, let me show you this one. If you certainly feel free to type along here. We're going to look at a different set of data with this source category of lab/GitHub. And so we're going to use GitHub as the example set of data. Now, GitHub, if you're not familiar with it, not a Sumo Logic thing, it's a online repository, if you will, where people can upload and download code and changes are tracked. And it's a good way to track changes of code. And so within that code, we're going to have the idea of a committer. So here's an example right here. And the committer would be the individual that committed the code. And within here, there's the information about the committer. So there's the name, email address, and username. But what we're going to do is we're going to play with this email address. So for this first line, we're saying just look at the GitHub data and look for that committer. Oh, got a typo on there. That's why it's not pulling any results back. Cool. So now I have my committer highlighted. Now what I want to do is I want to take that email address and I want to start to extract it out. And so what I'm going to do is I'm going to use the parse statement that's provided in the lab, just to save me a little bit of typing in here, and use it to help identify where an email address is located. So with this string of text, we're saying, look for the word email, look for the quote, look for the colon, look for the quote. Then whatever's in there, that will be the email address. So now when I run this line, I should get a new field called email address with all those email addresses extracted. And I do. So here's an email address, here's an email address, et cetera, et cetera. What we can do though with this, and this is the point of lab 3-8, is we can now parse that email address into two separate fields of a user and a domain. So let's say we want to go ahead and do exactly that. The system knows what an email address is or how to locate it, and it now knows what a value for an email address should be. With this next line, we're now going to parse this field even further. So essentially, the point of this lab is to show you that you can parse a field and then parse it even further, which is kind of helpful. So what I could do is I can parse the field of email because the system now knows what a field of email is. And I can say, use this pattern when looking at the field of email. Look at the @ symbol and look before it and look after it. So before the @ symbol, we'll call that users. After the @ symbol, we'll call that domains. And now when I run it, the system's going to look for those email addresses. It's going to look for the @ symbol, and then it's going to kind of explode out that email address into users and domains. And so now I have my users column, I have my domain, and then I have my email. And now I could go ahead and let's say I want to count by users. Well, the system knows what a user is, and I can just do count by users, and now it's going to show me all the users that committed code to GitHub over the last 15 minutes. And then if I want to just do the top 5 users, here we have 25 users times 6. That's a lot. If I just want to see the top 5 of them though, I can use that top operator again. How many do I want to see? The top what? The top 5 of users, and I want to do it by count. And so now it's going to take that whole list, sort it, and then just include the top 5 and cut off the rest. And so the reason we did this lab, the top portion is not really the benefit of it. It's this portion here is showing you can create a field or parse out a field and then even parse it out further. And this is helpful. Email address is a great place to use this. Another place that might be helpful is let's say you ingest source IP : source port, and you want to expand that out into IP and port. Then you could use the colon as the trigger for identifying where that separation should occur. All right, cool. A couple more that I want to show you, and then once we get into lab 4 and 5, then I'll give you a few moments to go ahead with those. But this last one, lab 9 and 10 go together, or 3-9 and 3-10 go together. So let's show the source of data and then let's show why we're doing this lab as well. Now for this one, we're going to look at snort data. You may have used this source category before, but I think we're going to use it a little bit differently. Because within this set of data, what I want to show is this section right here. And what I'm showing here is the fact that there are 2 IP addresses in this log message and in each one of these log messages. And you might imagine they might be a source destination type thing. Why there's 2, doesn't really matter, but there are 2 in here. Now, if I go ahead and start to say, parse out this data, let me just grab the regex just to make sure I don't make any typos. Sorry about that. Now, if I tell the system to look for IP addresses using this pattern of number, it's going to do exactly what I tell it to. It's going to look for number or an IP address in the log message. When it finds it, it's going to display that IP address. It's going to consider itself done, and it's going to go to the next log message. Look for an IP address. If it can find it, it'll display it. If it can't, it'll drop it, go to the next IP address, and so on and so forth. Now, that's great. I now have those IP addresses, and so there's the first IP address, and here's proof that it shows the value of that IP address. But the problem here is, what about that second IP address? It's being dropped because the system's looking for the first one. It finds the first one, and then it continues on. Now, what if I want to include multiple IP addresses or multiple patterns that match when looking for an IP? How do I do so? Very simply, I'm just going to add the option of multi to the end of my query line. And what this is telling the query line or the system to do is look for multiple occurrences of the pattern. So look for an IP address. If you can find an IP address in a log message, great. Count it or look for it. Now look for another one. If you can find it, great. Look for another one. If you can't find one in there, okay, now you're done, and now go to the next log message. So now when I run this, what I'm going to have is for each log message, I'm going to have 2 IPs, and essentially I have the log message duplicated. The way it displays it's a little odd, but it is here. So the first IP address in the first log message is 120.193. There's that IP address. The second IP address in that log message is 10.67133. There's that log message and that IP. Next log message, the first IP is 236.119. There it is. The second IP is 1030. There it is. So it's going to display each IP on its own line, which is going to give you kind of duplicate lines, if you will. Now the question comes up here, and I'll just anticipate it because usually someone asks it, is, all right, that's great that you're treating these IPs the same. But what if I want to treat them differently? What if I want to treat these as a source IP, the first IP as a source IP, and the second IP as a destination IP? How do I do it? Well, this would be a case where you'd want to use either parse UI or parse anchor to produce that. Same end result, it's just how you get there. But essentially, you're going to use the TCP as the anchor. So what we're going to do here is we're going to highlight this, and we're going to parse the selected text. We're now going to go through and just give these labels. So we're going to take this first IP, click to extract the value. It's going to turn into a star, and we'll call this source IP. We'll take this guy here, highlight it, click to extract this value, and call it a source port. Take this guy here, call this destination IP. And then this guy here, destination port. When I enter that, the query gets put in the section of my query window. So there is that UI portion that I just created. And now when I run this, the system's going to look for a bracket. It's going to look for a TCP. It's going to look for a bracket. It's going to look for a space. The first thing it finds, it's going to call a source IP. It's going to look for a colon. The second thing it finds, it's going to call a source port, and so on and so forth. And so this is a better way of, if you want to take those IPs and treat them differently and report on them, this is how we would recommend you do so, at least. Okay, good. Now the last part of this lab, this is going to be 3-11, is just taking advantage of field extraction rules. Now hopefully you've come across field extraction rules already. If you haven't though, let's go through them because they're really important to you and to your users. And let me go ahead and show how they can be used. And hopefully you've seen this before, like I said, but so I'm going to look at the Apache access data. Now what I've done is I've just said, show me Apache access data. And in the field browser, and that's what this section over here is called the field browser, it's going to show us those fields that are available for us to utilize in our queries. Basically those fields that the system knows about, knows how to locate information for. And so within here, we have a field for source IP. We have a field for a URL. We have a field for status code. We have all these fields that are available for us to utilize in the query. And so if we want to now go ahead and look at status code equals 404, now we can truly say, show us status code equals 404, rather than just saying, show us 404. And so when I run this, the system is going to look for all those status codes that have a 404 and only display them. Now, how is this set up? This is set up in the field extraction rules themselves. And under manage data, under settings, under field extraction rules, this is where they're configured. Now, in this instance, you'll have access to them. In the real world, you may or may not, just based on the administrator deciding whether or not you deserve to have access to them, if you will. But if you don't, at least now you know what to ask for. And the way these are set up is basically you would just give the rule a name. You're going to tell the system what set of data you want it to utilize. So basically, when any data for Lab Apache Access gets ingested, this is the parse expression I want to apply. And so what this expression is doing is saying, all right, anytime any data for Lab Apache Access comes in, look for number. When you find that, call the source IP. Then look for the method, the URL, the status code, etc. And so now the next time data comes in, those rules will apply, and then we can utilize those rules in our queries like I was just starting to do so. So now if we want to go ahead and count by source IP, we don't have to do the regex of number, because the system has already found a source IP, and we can just very simply take advantage of that field. And as long as we type it in correctly. And so now we're counting by source IP. And we didn't have to explicitly tell the system how to locate it because we had already done so, or somebody in our organization had done so already. Okay, cool. Lab 4, I think Lab 4 I'll give you guys a head start on. So Lab 4, let's go ahead and just do the first portion of the lab. So just Lab 4-1. The second portion is just, it's a little repetitive, so just in the essence of time, we'll skip over it. So Lab 4, go ahead and do. I'll give everybody a moment to jump into it, and then I'll explain why we're doing it. And for these labs, I'd encourage you to read them kind of like I did earlier as a word problem of what we're trying to get you to solve for, and then helping you understand, you know, these are the pieces that you'll need to help the system define. So let me go ahead and grab it and give you guys a head start. Okay, so let's go ahead and start here. So with this one, what we want to do is we want to write a query that scans through Lab Apache Access logs for the last 60 minutes and returns the number of successful HTTP requests, which we're considering a status code equal to 200, versus the number of error HTTP requests, which we're considering a 404. So the goal here is to compare 200s and 404s. If it's outside of that, we don't really care about it for this purpose. So let's go ahead and start to do so. So in the very first line, we're going to say, look for Lab Apache Access data, as we've done multiple times today. We're going to make sure we want to do the last 60 minutes. And then I'm going to start to comment a few of these lines off and just work through them to help you understand what they're doing. Okay. Now the second line here, we actually could exclude, because what the second line is doing is saying, look through that Lab Apache Access file, log message. Look for the HTTP, look for the slash, look for the 1.1, look for the quote, whatever is after that, that will be the status code. But we don't necessarily need the second line because we already have the field extraction rule in play that's helping the system identify what the status code is. So technically, we could leave the second line out. If you have it in there, of course, leave it in. Not a big deal either way. When we run the second line, though, now we're going to have those status codes extracted. So now we have a field for status code and the value for status codes. Now we're going to use this if line here. And what this line is going to help us do is to start to create a tally system, if you will, of the amount of successes we have. And so the way this line reads is, if the status code is equal to 200, go ahead and tally a 1 when this statement is true. When this statement is false, tally a 0 as a success. So now when I run this, I'm going to have a new column called successes, and I'm going to have a tally system starting to occur. The status code is equal to 200 here. Is that considered a success? Yes, it is. That statement is true. And so we tally a 1 under successes. Here is a status code of a 304. Is that considered a success? No, because it's not equal to a 200, and so we tally a 0 here. Here's, let's see, another one. Here's a 304. Same thing. That's not a success, so we put a 0. Now, this next time, we're going to do kind of the opposite. We're going to take 404s and look for them and tally a 1 for them as a client error and a 0 for them when that statement is false. So we're going to click Start, and now we're going to have a new column for client errors. So here's a 200. Is that a client error? No, because it's not equal to a 404, so we put a 0. Here is a 304. Is that equal to is that a client error? No, because it's not equal to a 404. Is that considered a success? No, because it's not equal to a 200. And then I'm just seeing if we have a 404 handy in here. And I don't want to waste time looking for a 404. So what we're now going to do is we're going to take all those columns and add them all up. So we're going to take the success column, add up all the ones, and call that a success count. Take all the client errors, add them up, and call that a client error count. And now when we do that, now we can clearly see over the last 60 minutes, there's been 173 successes and 7,800 fails or client error count. And so this is a helpful way that we can take our data and start to look at it in kind of a different way using the if and then and using the kind of tally system to add these up. Now we're going to use this portion of the query a little bit later. The last query we'll do today will be kind of a mega query, if you will. And what that's going to allow us to do is to take our data and take a bunch of the things we're learning today and produce one big kind of result from it. So we'll do that a little bit later. So we will use this portion in a few, probably about half an hour or so. So you don't need to bookmark it or anything like that, but it will look familiar because we'll use this and some other pieces that we're going through today. All right, good. We're doing okay. So let's go ahead and let's do lab 5. In fact, I'm going to give you time to do lab 5. I'll give you a few moments. What this is doing, and go ahead and start now. What this is doing is allowing you to utilize a subquery in the way that you're going to have essentially a parent query, a child query, and then the child query will produce some result and transfer that result to the parent query. So that's the basis for what this lab is doing. But I'll give you a few moments to read through it, play with it, and then I'll go through it. Okay, so I'm going to catch up to you guys now. So what we're doing here, and hopefully the graphic kind of illustrates what we're doing here, is using that child and parent query together. So we're having a child query create some sort of result, and then we're passing that result into the parent query as a keyword. So first, we're going to go ahead and start to set up the child query. Or actually, first we should do the parent query, but that's pretty straightforward. But so I'm going to go ahead and grab the child query. So this child query is going to create a result, and more specifically, a single IP address that is associated with this string of text. So in that respect, we're saying, look for that string of text, and then go ahead and start to find a single IP from that string of text, so that has the most frequent occurrence of that string of text. If that makes sense. I hope it does. So when I run this now, what I'm going to see is a single IP, and in this case, this single IP has 130 results of that string of text. Now with the parent portion, now I can take this IP and pass it back into the query that is the parent. And so the formatting for it is going to be this right here. So we're saying, even though the source category line is the first line, the subquery line is going to run. It's going to create a single IP address. We're then going to take that IP address and then pass it up to the very top. And then we're going to, essentially, it's going to be looking like we're going to search for then that IP. So it's going to look like that with that single IP that's passed up. That's basically what the system is doing. So it's a really helpful way. This is actually a newer feature for us. We used to do this through join statements, which worked, but were really a bit of a headache. This provides a much easier way to do that. So basically, the idea here is you have a subquery, and then you can pass it to the parent. That's really what we want to illustrate in a nutshell, which I think can be quite helpful. Now, Lab 6, I'll give you guys a few moments to do. This is kind of a fun one, not to say that the others were not. But what Lab 6 is going to let you do is plot clients on a map. So I'll give you an opportunity to do it, but let me talk about how we do this or how you can take advantage of this. So what this is going to allow you to do is use the geo lookup operator to start to take IPs and look up geographic information about them, and then you can utilize that information. So one of the advantages of using Sumo Logic is that you have access to this geographic information. Now, there's a ton of other advantages, of course, but this is one of them. What this is essentially a big lookup table of NewStar data. NewStar is an organization out there that does geographic information associated with internet traffic. So they specialize in this area. And so what we're allowing you to do is utilize that data. And so with this query, what we're doing here is we're starting to extract IP addresses using parsing. So we're just grabbing those IP addresses. And then assuming the IP address is a public IP address, you can start to look up that IP address against that lookup table and extract information that's geographic based, such as the latitude, the longitude, the country code, the country name, the region, the city, the state, the zip, continent. There's one other that I'm forgetting. And that's what this query is taking advantage of, is the fact that you can utilize this. So in the first line, we're grabbing the Apache data like we've done many times and we'll continue to do. The second line is we're just grabbing that IP address. So we're telling the system to parse out the IP address. Once again, technically, we don't even need that line because the system already knows how to locate an IP address, but nonetheless, we'll put it in case the field extraction rule is not in play. Now, the third line is where you're going to utilize the lookup table. And the way, and if you haven't deciphered it, the way this works is it actually reads better a little bit going from right to left. Because what it's saying is it's taking the value of client IP, so the system knows what a client IP and knows what the value of a client IP is, and it's comparing it to the IP that exists within that geolocation lookup table of NewStar data. And from that data, it's going to, assuming once again the IP address is public, it's going to extract the latitude and longitude. And we could also say country code. I think that's even part of the bonus question. Country name. There are other fields we can extract. They're all very thoroughly documented. But by doing so, we're basically taking each IP and we're looking up a latitude and longitude for it. Now we're going to take all of them and we're going to count them. So we're going to take all those latitudes and longitudes, group them together, and just count them all up. When we do so, we get results. So we see that for this latitude and the longitude pair, there were 2,000 results. For this latitude and longitude pair, there were 1,900 results, so on and so forth. Now the goal here is always to create a map. Now we have geographic information here, but we don't have a map. And so now to take advantage of the mapping feature, well, there's a mapping icon, and you go ahead and click on it. And now you'll have a map displaying your geographic data or the information that you just extracted plotted on that map. The map itself is dynamic, which is kind of cool. So if you want to go ahead and zoom in on a central part of data, you can go ahead and do so. You could also imagine you create this map showing you where your visitors are coming from, for example. Maybe you have this up on a command center or a NOC environment, and if somebody comes in from Russia or China, they're going to show up on this map, and then maybe you go ahead and figure out, are they a legitimate user? Is it someone on vacation, or what's going on there? And so why we want to do this lab is one, to show you that you can plot your information on a map. The other thing we want to show is just how easy it is, because really this query can be done with really about 3 lines. Tell the system where the data is, tell the system what fields you want to grab from the lookup table, count them all up, click on the little map icon, and you have a map. So really easy to set up, and really easy for you to take your data and start to turn it into that format, which is just visually very pleasing. All right, good. Let's see, Lab 7. I'll give you guys a moment to do Lab 7. Yeah, I'll give you just a quick, just a quick moment. The reason being, you may have done this already, so I don't want to waste too much time on it if you've done it already. But if you haven't, it's certainly valuable. And what it's showing you is the ability to format results, and more specifically, format them in a way that's going to be more reminiscent of Excel, where you're going to have rows and columns. So you can essentially take data that has 3 different points to it. I don't know if that's the proper way to describe it, and then chart it out into that tabular Excel feel. So let me grab the query. Let me run through it. Like I said, you may have seen this before, so let's go through it quickly. But it is a very helpful feature, the transpose operator. So first 2 lines should look pretty familiar by now. We're grabbing that Apache access data. We're grabbing those status codes. The 3rd line, now we've introduced time slice in other segments of our training, but I don't think I've discussed it today. So I will, because it's a really helpful feature as well. Because what I'm doing right now, without using those last 3 lines, is I'm just saying, look at the log messages for the last 15 minutes and show me those status codes. But what I can do with the time slice is I can introduce time buckets, if you will, where I can say, all right, instead of looking at my data for the last 15 minutes in one big group, break it out into buckets of time and show it into me in 1-minute increments. So instead of looking at the last 15 minutes, which would be 12:50 to 1:05 local time, show me my data at 1:04, at 1:03, at 1:02, and so on and so forth. So this line here, time slice by 1 minute, is just saying how what time period you want those buckets of time to be. And now we're going to take advantage of those buckets and display our status codes and our time slices together. So now when I run this, I'm saying, show me all the time slices, all the status codes for each time slice, and the count. And so now I can see there were 83 401s at 1:02, 72 401s at 12:53, so on and so forth. But now what we really want to drive home with this lab is the idea of turning this into that Excel look and feel. Because I can use the transpose operator here to say, take my times, make those the rows, take my status codes, make those the columns, and then at the cross intersection will be the value. And now I have that right here. So if I want to see the amount of 404s at 12:55, look at 404 column, look at 12:55, and the cross intersection will be that count. Much better way to present the data. Okay. Lab 8 is going 8-1 and 2. Let's go over both of them. One is much more useful than the other, but let's do both of them anyhow. So with lab 8-1, the goal of it is to look at or calculate the difference in number of requests over the last 15 minutes. And so what we're going to do is, let me grab it, is take our data and start to just manipulate it again, but the same basis of code we're going to use. So once again, this will look familiar. So we're taking our lab Apache access data, we're taking our time slices, and we're going to count by time slice. Now, in this case, we're just counting by time slice, which I don't think I've done yet, of counting just by that. And what this is showing, just in case you're curious, is it's going to show the count is going to be the number of log messages that match that 1 minute period. So rather than just looking at the 404s or whatever, how many log messages came in essentially from 106 to 107, from 103 to 104. And that's what this is showing us, just the count of messages. Now we're just going to sort those in ascending order. By default, when we do a count by time slice, the times are in somewhat random order. So we're going to sort them and, like I said, put them in ascending order. So now we have our 1253, 1254, et cetera, et cetera. Now, remember, we're trying to calculate the difference in number of requests over the last 15 minutes. Very simply, we're just going to use the diff operator. And we're going to want to do a diff of the count, because that's the thing we want to look at the differences of. So now when I run this, at 1253, there were 431 log messages. At 1254, there were 4,000. The difference between 4,000 and 400 is about 3,600. Next line is 4,000 to 3,600. Difference is about 400, and so on and so forth. So it's very simply, taking the first line, taking the second line, and showing the difference between the two. As the diff operator might imply, that's exactly what it's going to do. But now let's look at one that's a little bit more useful. So this will be 8-2. I'm going to grab the code once again, just to save a little bit of time and typing. And let me go ahead and paste it in. So what we're going to do here, the first line is having us identify the Lab Apache access data again, and only those log messages with the 404. And the goal with this lab is to calculate the moving average of 404 occurrences over the last 15 minutes. So we only care about 404s. If it's not a 404, it's not relevant, at least for this discussion. We're going to do the time slice. So we're going to take our data, break it out into 1-minute buckets. And then we're going to count as error count by time slice. And what this basically means is count the log messages and call them error counts and do it by time slice. So essentially the amount of 404s will be the error count. So now at 1:06 p.m., there were 168 error counts or 168 404s, same difference. We're going to sort them, so just put them in order. And then we're going to use the moving average operator or the smooth operator as the operator against the error count. So we're going to take the error count and smooth it and call the result rolling average. So we're going to click start, and now we're going to have a new column for rolling average. And now the system is determining a rolling average. So at 12:55, the error count was 33. The average of 33 is 33. At 12:56, we're going to take 33 plus 133 divided by 2, and now the rolling average is 83. The next one, we're going to take these 3 divided by 3, and so on and so forth to get that rolling average. Now, what the bonus has you doing is creating a line bar combo chart. Curious if anyone figured out how to do it. You've probably figured out how to do the line chart, certainly, or the bar chart. Those are pretty easy. But how do you do the combo chart? Well, there's this little gear icon right here that has settings. So I'm going to go to the line chart. I'm going to go to the settings, and I'm going to go to change property. Oh, actually, sorry, not change properties. Change, where is it? Change series. Sorry about that. And so here I can go ahead and change the chart type. So what I can do here is I can say for the error count, I want to show that as a line. The rolling average, I want to show that as a bar, or vice versa. Actually, we'll do the error count as a column and the rolling average as the line. And now when I save it, I have both combined. So I have the bars representing the error count for that 1-minute period, and then I have this light blue line representing the average for the rolling average for those periods of times as well. Okay, good. Let's see, Lab 9. Lab 9 I'm going to skip over, but let's go to Lab 10. It's very similar. Lab 10, and I think we'll just do, let's start with Lab 10-1. Let's see. We'll do a couple of these, not all of them probably. So with Lab 10, what we're going to introduce is the idea of log reduce, which you've probably seen in a demo before, but you may not have had hands-on experience with it. So let's go ahead and set this up. So we're going to go ahead and once again, we're going to look at the status codes for 404. So we're going to take the source category, actually, keeping the same basic query. And I'm just going to grab this guy and bring it on in here. So once again, I'm just looking at status codes that are equal to 404, and I get a bunch of log messages. Now, here's where we want to introduce log reduce, because as you may have seen before, what log reduce is going to allow us to do is take our log message and look for patterns within that log message and then group them together. So here we have 1900 log messages. Well, if I click log reduce, it's now going to take all 1900 messages and group them together based on patterns that the system is finding. And then it's going to show us those patterns. Now, the majority of these patterns for this example will show us user agent information. And what this is showing us is information about the browser that the individual is using when they visited a website. So we can see here that there were 241 of this user agent string matching this pattern. Now, this is certainly helpful to know that we now have 241 visitors that are using this type of browser, this configuration. That's great to know. But what if we want to compare that to another time period? That's where log compare comes in. Because what log compare is going to allow us to do is to do a log reduce for one time period, do a log reduce for another time period, and then compare them. By default, it's going to do a 24-hour period. So what's occurring now is basically we're looking at our status codes for 404. We're grouping them together for the last 15 minutes. So we're essentially grouping them from 1 o'clock to 1:15. We're then going 24 hours ago. So we're going yesterday to 1 o'clock to 1:15, grabbing those 404s, combining them in the log reduce patterns, and then comparing the two. And so what this is showing us right here, for example, is between yesterday and today at the same time, today there's been an increase by 4.5% of this user agent. Well, that would certainly may be helpful to know that there are now more people coming in with this browser configuration. Maybe there's something we need to support. Maybe this browser type is becoming more popular and we need to optimize code for it, or whatever you do with that information. Conversely, let's see, we see there's been a decrease by 10% of this agent string. Well, conversely, maybe this one is becoming less popular, people aren't using it as much, and maybe we don't need to support it anymore. Now, what we can also do here, and this will be, I'll skip over section 3 of this, I'll go straight to section 4, because what we can do is we can use the is new here to show us those things that are new. So let's say, this is great, but what we really want to see are those user agent strings that are new today that did not exist yesterday. Well, if I do where is new, I'm going to get exactly that. And now it's going to show me the 404 information from yesterday, the 404 information today, grouped together, combined, and now it's going to show me those that are new. And so what this is telling me is that this user agent string did not exist yesterday, but today it does exist. And so that might be good to know. Maybe there's a new type of Mozilla that's out that now we need to support, a new browser that's coming out, and this allows us to view that. So what we want to show in this lab, I know we did it a little quickly, but there's really some great pieces of information in there, is using log reduce to take your data and have the system look for patterns in the data and combine them to group them to give you a kind of a needle in a haystack view of what's going on. Using log compare to compare two different time periods to compare and see what was occurring during this time period, what was occurring during this other one, and then what are the differences between them. And then the is new to take advantage of seeing those things that are new versus not. This is going to let you clearly see these things are new today that did not exist yesterday. All right, lab 11, I'll give you guys a moment to do. This is going to explore the outlier functionality. So why don't you go ahead and do it? The other thing I'd encourage you to do is play with the bonus. So the bonus portion of this is to play with the settings for window, consecutive, threshold, direction. And so I'd encourage you to do so. So I'll give everybody a moment or two to start running with that one. And then I'll jump in and explain some of the highlights. Okay, so the first couple lines of this query should look pretty familiar. Once again, we're taking the 404s, we're looking at just the Apache Access ones, we're doing our time slices, we're counting those status codes as error count by time slice. So basically, when we run those first 3 lines, for each minute segment, we should get an error count or the number of 404s. Now, where the outlier comes in to help us is it's going to allow us to identify events that are outside the threshold. Essentially, using the outlier command, our outlier operator, we're going to develop a threshold, and then we can start to be notified when these things fall outside the threshold. So as you discovered, the parameters here are customizable. And so if we run it just as it is, just to explain the outlier a little bit deeper, this is where we are going to start to use these parameters as portions of the math in determining how an outlier is calculated. So using this math, quote unquote math, if you will, the system is going to go through and start to develop an upper and a lower threshold of that's considered acceptable or within the range. So for this first value, the range based on the math is between 188 and 71. The value is 142, which is in that range, and so that's considered acceptable. The next one, the math changes the range, and now the range has changed from 70 to 189, so it's gotten a little wider. The value is still within that range, and so that's considered acceptable and is not an outlier. Let's see if I have any examples in here. Let me expand my search out a little bit more. Oh, okay, here's one, kind of hidden, but so here at 11:33 a.m., the equation figures out that the range is between 77 and 182. The actual is 188, which is outside that range, and so we see an error count indicator here, indication that the outlier has taken place. But this way is not, or may not be the best way to express this data. Well, I can see that, an outlier did occur. I see it right there. I can't really clearly see it. As you saw, I had to scroll through a few screens and then look for it. So the system is letting us know, hey, you could represent this data in a line chart. And so when I click on the line chart, now what I see is over the past 3 hours, there have been 3 outliers based on the math of how it's being calculated. Now, this math is customizable, and as you probably hopefully been playing with for a few minutes, you can change things like the window, which is going to be the amount of trailing data points you're using, the threshold, which will be the standard deviation that you're using. And that's going to change the way the outlier is calculated, or more importantly, the threshold is calculated. So I could go ahead and say, instead of using 3 standard deviations, let me go ahead and use 2. And by doing so, now I'm going to see that there were many more outliers because my range is now much more narrow. And so I'm still looking at the same exact set of data, but now the system is letting me know, hey, if you look at it this way with this outlier math, the range is more narrow and there's going to be so many more outliers. Now, another thing you can utilize here, and maybe you played with it, is direction. What we're saying here is show us those places where the amount of 404s is above the threshold and below it. But you know what, in my mind, and you would probably agree, having less 404s than is what is expected is kind of a good thing. I don't really need to know that there were less 404s because, I only want to know when there are more. That's bad. But if there are less, that's good. So what I can do with this direction is say, instead of showing me above and below the range, the cloud, just show me above. And now the system is going to only show that there were, about 5 outliers over the past 3 hours, and these were where they occurred. So in those 5 points, the amount of 404s was greater than what the system was calculating based on all the math. So outliers is a really powerful way, easy way as well to have the system help you in determining what is an acceptable range for things. It's still going to be up to you to decide what these values should be. And the best way to figure out what they should be, well, one is, of course, entirely up to you. But what I would encourage you to do is take a normal period of traffic or data and use that as kind of your guide. So, in this past period of time, has traffic been pretty normal for us? If it has, maybe we use a threshold of 1. Excuse me, actually, I meant to do a threshold of 4 to show, hey, things have been pretty normal. We have a wide cloud, and, as long as it's within this wide range, things are okay. Maybe you want to narrow that down and have it much more, a tighter cloud, a tighter threshold. Just up to you what's going to make sense. But I would encourage you to look for a normal period of time and then develop a outlier math based on that. And then the next time those outliers occur, that math should help you out. So hope that makes sense. All right, good. Let's go ahead and this will be lab 12. Very easy to do, very easy to illustrate, and let's show what it's going to do. This is going to be used to predict future trends, so you can probably guess what this operator is called. It's called predict. So what this is going to allow you to do is have the system start to predict what future values will be. So let's say we have these 404s, these error counts, and we have all the old ones. Well, what if we want to have the system start to predict what the error count will be going forward? We can do so. Very simply, we just use the predict operator. We tell it we want to predict on the error count. How frequently do we want it to predict? We want it to predict every minute. So we'll click start. And now the system is going to start to use math to model what the prediction, what the previous values have been, and then what they potentially will be going forward. So here we have old data, but now let's fast forward. And now we have newer data. So here, let's get this guy out of the way. So here we're starting to see at 122, there were this many errors, actual errors, and here's the count. And then we see the prediction starting to occur. So the prediction is trending kind of upward. So it's expecting 135.17, 0.19, 0.21. It's subtly heading up, but it is heading upwards. We can put that data into a line chart once again, and then we can see the previous values for the error count, and then what the prediction is predicting using that dark blue line. And we can see it's pretty flat. I mean, it is kind of upward, but for the most part, it's pretty flat. So the prediction operator is a good way to help have you, let the system decide what's going to occur. Okay, let's see. Lab 13, I think I'm going to skip over just for now. This is one that I probably encourage you to go back to at some point. What it's going to have you do is utilize the transaction operator. And where this is helpful is it's going to allow you to look at a group of data, but use a single or a unique identifier to go through that data. So using something like a order ID, a session ID, an IP address, something like that, and looking through different sets of data and kind of tracking that through that data. So I'm going to skip over it for now, but something I'd encourage you to go back to at some point. Lab 14, let's go ahead and play with metrics for a few minutes because we haven't really done so, certainly not today. And it's worth going through because you can. So we've been going through logs today, and many of you may be using Sumo Logic for log usage, and that's great, and strongly encourage it. But we also allow you to ingest metrics into Sumo Logic and utilize metrics in a similar way. And so let's go through some of the steps that allow you to play around with that. So this is going to be this will be lab 14. And so, actually, I don't really need that. Let me just start typing it in. So in order to do a metrics search, we're going to do a metrics, we're going to need to open up a metrics tab. So instead of a log tab, we're going to do metrics. So we'll go up to new, and instead of doing log search like we've been doing a few times today, we'll just choose metrics. Now the metrics interface is similar and different at the same time. You have a chart area here, but down here is where you have a query window. So instead of the query window being at the top for log search, it's down here for a metric search. And so what we can do is we can start to look at some metrics that we've brought into the system. And this is really going to help us looking at KPIs or key performance indicators over time. So for the very first one, we're going to look at the type. So we want to look at a query to search for all of our successful bookings for the last 60 minutes. So we'll specify last 60 minutes. That's the easy part. And then we're going to look for bookings. So we're going to look at the type will be equal to bookings. And then we're going to look for the metric that is associated with success count, because we want to see the values for those successes. So similarly in how we use source category earlier to say, look for this subset of data, that's kind of what we're doing here. We're saying instead of looking at source category labs Apache access, we're saying look for the set of data for bookings. And then look for the metrics specific to those bookings of success count. And now we see over the past 60 minutes, here's the success count. So we see, you know, at 12:34, there were this many successes, then here, you know, so on and so forth. So we're starting to see all those successes displayed out here in 30-second increments. Now what we can do is we can look for a different type of metric at the same time. We can look for failed bookings. Now for this one, I hope there's data in the system. I'm crossing my fingers. Let's see. Okay, there's not. That's disappointing. But in the real world, this would be more ideal, because what we're saying here is show us success counts and then show us fail counts at the same time. Now, in this case, we don't have any fail counts. And like I said, in the real world, that would be ideal. If you don't have any fails, that's great. But unfortunately, we just don't have any of that data in here right now. So I need to get that kind of tweaked. So I apologize for that. But we can still look at some of these other features. Let's see, what can we do? We can do logs to metrics instead. There should be data for that. All right, let's play with logs to metrics then. So this will be lab 15. And so what this is going to allow us to do, and let me just copy some of this real fast. Okay, cool. What this feature allows us to do is to extract metrics from logs. So what we can do is we can take our logs and we can grab metrics from them and then utilize those in our queries. Doing so is going to help save space. It's also just a different way to look at our data. This is a new feature that we added. It's been pretty popular so far. So let's go through an example of how it works. So to do so, we're going to actually go to a different set of the system. We're going to go to the manage data on the far left, and we're going to go to settings. And then under our settings, we should have a logs to metrics section. So we're going to go into there, and we're going to create a new rule here. Now to do so here, we're just going to essentially kind of fill in the blanks. So we're going to tell the system what log messages do we want to parse. So we're going to go ahead and give the rule a name. So I'm just going to use my initials. We're going to tell the system what set of data, so what scope, and this is referring to the source category that we want to utilize. So where is our data that we want to parse these log messages from? So it's going to be labs/Apache/access. And then what parse expression do we want to utilize? We can use the one that's in the lab itself. So we're basically saying when any of this data comes in, use this parse expression in the data to grab these fields. So to create a field for IP address or source IP, for method, for URL, very similar to field extraction rules. In fact, the parse statement is nearly identical.
Josh, we do have one question coming in, and
sure.
This one is one I wanted to check with you. If you can't see create new in the logs to metrics tab, is there something your admin needs to enable for you?
Yes, I guess so. It isn't, let's see. Yes, you would need to enable, sorry.
Is logs to metrics a capability to be enabled? Yeah, okay.
Yeah, it is. So you probably just have a view into it, so that would be why.
Right, but you should be able to see it from any training account, correct?
Yes, absolutely. Can somebody confirm that they can see the logs to metrics and have the ability to add new?
I'll try it, but
okay.
I'll also try and resolve it for the person who can't. Thank you.
Okay, no problem. So if you don't have access to this, if you just want to follow along, and we'll make sure that there's access going forward. So let's see, what do I have so far? So I have my parse statement. So I'm simply saying, here are the logs, here's how I'm going to parse these out. Now what I'm going to start to do is start to take these fields that I've parsed out, and now I can start to turn these into metrics. So I can figure out which do I want to turn into metrics and which do I want to turn into dimensions. And this is going to help with allowing me to do the query with the metric itself, and then the dimension will help with aggregating the result for that specific metric. So I'm going to grab the dimensions for source IP and URL. And now I'm going to click save. Where's my save not there? Let's see, what did I do wrong? I'm save. Oh, I forgot to do count the number of log messages. I have to turn this into a metric. Sorry about that. So I'm going to go ahead and call this metric. I don't know. I'm not feeling very creative. I'm just going to call it metric 1. Not feeling very inspired with my names today. And now let's see. Now what can I see? Let's see. Why is it not letting me save? I have my dimensions. I have my metric. I don't have to do that. Okay, now I can. Okay. So what it did now is it's taking that information from the labs, from the logs, and turning them into metrics that I can utilize. So now it still might be running, but let's see. I should be able to now do this, and let's see, are my metrics in there? Now they're still building. That's a bit of a disappointment. It's going to take a few minutes to display. Let's see. Yeah, it's still calculating. Let me just see if I can find something in there. Okay, Stacey just enabled log to metrics for those of you that were having problems, so I apologize for that. But it looks like I'm having a little bit of issue with it anyhow. So if you're not able to see it, if you want to log out and log back in, but to be perfectly frank, I think I'd probably skip it. It looks like I'm having a little bit of an issue with it. So I'd probably just recommend that we could probably continue just due to time. So logs to metrics is great. It works, but I don't know why it's not working for me right now. But I don't want to troubleshoot it with you guys on the line. So I apologize for that. And I encourage you to probably play with it on your own though. So let's go ahead and continue and just kind of skip over that. So let's go back to looking at just a couple of the metrics in there. So I'm just going to use the examples that are in here rather than the logs to metrics example. So in this case, let's go ahead and do, this will be lab, should be number 16 for you. So what we're going to do here is we're just going to go back to looking at metrics, and we're going to use the time shift to help us look at metrics over different periods. So very similar like we used log compare. In this case, we're just going to do it with metrics. So I'm going to do a new tab for my metrics, and I'm going to look at 2 different metrics. So the first metric I'm going to look at is associated with latency mean. So what this is showing me now is my latency mean over the last 15 minutes for, and these are the values. But now what I can do is I can look at the metric for latency mean of 1 day ago by doing a time shift. So I can take that same line, but do a time shift of 1 day. And by doing so, now I'm saying, look at my latency mean for the last 15 minutes, so about 1:15 to 1:30 today, and then go to yesterday from 1:15 to 1:30 and show me the latency mean. And now what I can see is, or hopefully can start to see, is possibly some sort of comparison. Now here, they're pretty similar. The latency means have, spikes, but they're all, pretty similar. Now here, certainly I have a very large spike for my latency, where yesterday I did not. And so this might help me or clue me into, hey, something's out of the ordinary here. That's why I have this big spike here where I didn't. And so I can start to use these to compare the two. In lab 17, we're going to look at using the metrics and using different measurements for change. So this is going to look at kind of the same data, but how do you want to express the data? So this is going to be a new metric. And then we're first going to look at the types of packets received. So we're going to look at type packets received, and the search ahead helps me here. And I'm going to look at the metric associated with count. So what I'm seeing here for the last 60 minutes is the count of packets received. So for each, these are 30-second chunks, or actually 15-second quantizations, I see the count here. So the count is one way that I can express or measure change, but there are other ways to do it. Maybe instead of doing it via just straight count and number versus number, I want to do a delta, and I want to say, show me the difference between one data point and the next. And so now I can have negative values because one data point might be less than the other, and that is what the delta is showing me. Still the same set of data, just a different way to express it. Maybe I want to go ahead and look at this with the rate of change. So instead of using the delta, look at the rate of change. And now what this is going to show me is, once again, a different way to express the data. And what I'm going to be able to see here is the rate at which packets are being received, and whether that's increasing or decreasing, either increasing gradually or spiking quickly. And so same data, just a different way to view it, different ways to kind of define that measurement of change. And so that's what we're trying to show with this lab is there's basically different ways to look at the data, and how you want to express it is what makes sense to you and your team. Let's see. This next lab, this is going to be lab 18, which is going to allow us to look at metrics and logs together. So we're going to use kind of the same query that we did with the first metrics query we did with that success count. I'll get rid of that fail one because it's not showing up anything. But what we can do is we can now look at the logs that are associated with this time period. So right now we're looking at the metrics. And if you remember, if you either attended this morning or previously had attended a training where we did the travel logic use case, we used the metrics and the logs to look at the same set of data, and then use the logs to drill into that data and find out what was going wrong. And so that's what we can do here is we can say, all right, let's look at the metrics associated with bookings, but at the same time, let's go ahead and look at the source category associated with the training travel checkout service. And from that, let's go ahead and just look for errors. And I hope there's data in here for that. And there's not. Oh, I thought we had put data in here. Let's see. I missed something. Check out error. That's strange. Okay, that's odd. Now what this should show, and the lab shows it, but I wanted you to actually see it, is the idea that you could then have a heat map at the top, which would be showing you the amount of log messages that match your criteria. So you're looking at metrics. You're also looking at the occurrence of log messages that have the word error or string error in it, and then you can see both. And then ultimately you can take the heat map and drill into one of those sections to look specifically at those errors. But unfortunately, there's not data in here. Sorry about that. There's not data in here, which is odd because there was just yesterday. Okay, I apologize for that. I'll need to look into that, but I'll get that resolved. All right, so hopefully you at least picked up a little bit about metrics, even though we had a couple of issues here and there. But what I really want to show is that you can ingest metrics. If you have metrics to ingest, you can do so, and that there are ways through the system to utilize those. And you'll have better data than our lab data, so you'll actually be able to utilize them. So let's see. You know what? I'm going to skip over these next two labs only because these are creating and publishing a dashboard, which by now you should have done already. So I feel like we're probably okay with them. So that's why I think I'm going to skip over just to save a moment of time. If you haven't done these before, I certainly encourage you to do so. But basically, it's just telling you or showing you how to take the results and how to stick them in a dashboard. And then you can share that dashboard with other individuals. All right, let's get to lab 21, I believe it is. This is going to be the last lab that we do. And I think I'll do this one. I'll just do this one and then talk about it because there's a lot of things going on in it. A lot of things you've seen already, but a lot of things. And let's show why we're doing this lab. So what we're trying to do here is we're trying to create meaningful alerts. And what we're trying to do is, rather than alerting on simple counts, we want to create an alert that will notify us when the 404s increase at a higher rate than our overall traffic measured by 200. So if I tell you, and you may have heard me say this before, if I tell you you have this many 404s in a period of time, is that good or bad? I don't know, you need more information. But if I tell you have this many 404s and this many 200s, is that good or bad? I still don't know, but now you get some more information. Now you can start to figure out if it's good or bad. And that's what this lab is going to have us do, using some of the features we've used already. So there we go. So in the first line, we're simply saying, and we've done this before, we're saying, show us only those places where the status code is equal to 200 or 404. If it's not equal to one of those values, I don't care about it, for at least for this, this example. I'm going to take my data and I'm going to do a time slice of it. So I'm going to introduce that idea of breaking my data down into buckets of time, and specifically 1 minute segments of time. I'm now going to go ahead and go through my logs. And if I find a log that has a status code that matches or specifically equals to 200, I'm going to call that a success. And I'm going to tally a 1 as a success, like I did earlier. And then I'm going to do the same thing for anything that matches a 4. Now, the only values I'm going to have are 200 or 404. So if it matches a 4, it's going to be a fail. So now when I start this, now I'm starting to see, here's the status code of 200. Is it a success? Yes, it is. It's not a fail. That's why I have a 1 there and a 0 there. I'm now going to take all those successes, add them all up. Take all those fails and add them all up, but I'm going to do it by time slice. So I'm going to do it for each 1 minute bucket. So now what I can see is at 135, there were this many successes and this many fails. At 132, there were this many successes and this many fails, and so on and so forth. Now I'm starting to get something that's a little closer to apples, but I need to turn that into one more value to really be able to compare the two. And what I'm going to do here is create a failure rate, where I'm going to say take my fail count, divide it by my success count to give me a failure rate. Granted, it's not the proper way to do a failure rate, but it's a way to get a ratio. And that's exactly what I want to get. Because now what I see is, well, at 135, the failure rate was 0.043. At 132, the failure rate was 0.041. There's a difference between 1.043 and 1.041. And so I can start to see, this was good, this was bad. But I want the system to help me determine what is good and what is bad. I don't want to just kind of pick an arbitrary number. I want a good and bad threshold to be determined based on something. And so I'm going to utilize outlier again here, where I'm going to say, take the failure rate and find the outlier of it using all the math here. So I'm going to start it. And so now the system is going to take those failure rates and determine an upper and a lower threshold for those rates. And so now what I see is here at 131, the rate, the upper and lower limit is 0.036 to 0.054. The actual is 0.041. That's within that range, and so that's acceptable. The next one, range has changed a little bit based on the math, 0.037 to 0.05. 0.04 is within that range, and so all is good. Now here on the third line, though, the range is 0.038 to 0.047. This is outside that range, and so now I have an outlier indication here. Now, as I showed earlier, a line chart may be a better way to express this. I do need to change the scale of this. So I just need to put it in log versus linear. And now what I see is over the past 15 minutes, there has been one outlier or one time where the failure rate has exceeded the threshold. Now I'm going to expand this out just to get a little more data. But this is good, but let me just see if I can get a touch more. Okay, even better. So now what I see is over the last 60 minutes, there's been 2 times where the failure rate has been outside the acceptable range, outside the threshold. Now that's good, but I can't really see them within here. I mean, I can if I scroll through, but what I can do is I can add one more line here. And what this line is going to do is it's going to say, show where the failure rate indicator is greater than 0. So when I run this now, this should only show me 2 lines, which should show me those 2 lines where the outlier occurred over the last 60 minutes. Actually 3, one just occurred just a minute ago. So now I see over the last 60 minutes, there's been 3 times where the failure rate is outside the range of what's acceptable. Now that's great to know. 3 times this has occurred. Now, the goal of this lab, though, is to create a meaningful alert. I have meaningful information. I got really valuable information, but I don't have that alert component. And that's what I still need. I need that portion. So how am I going to do that? Very simply, I'm going to go to Save As, and I'm going to choose to schedule the search. I'm going to decide how frequently I want the search to run. Let's say I want it to run in real time. And now what's going to happen, the next time the condition is met, and the next time the failure rate indicator occurs, I will now get or can send out emails, or I could send out a Slack message via webhook. And now I can notify my people. And what I've done is I've now created a meaningful alert, which allows people outside of Sumo Logic to know that, hey, the failure rate is greater than what's expected. They can go ahead and fix it. Maybe they need to stand up a new web server or whatever they need to do. And they didn't even have to log into Sumo Logic to get that information. And so that's where that meaningful portion comes out of that meaningful alert, is that you can notify them of something as well as give them an indication of what is going on. In this case, the failure rate is greater than what should be expected, and then they can do whatever they do. And so I wanted to wrap up today showing that lab because it's a really cool way to take a lot of things we've done today, combine them into one single query that then outputs and gives you results that you can then be notified without even using Sumo Logic, which, a little bit of irony there that we're actually kind of discouraging the use of Sumo Logic in this use case. But I think it's useful because it gets just a broader exposure to what's going on in your environments. So let's see, I think that's about all for the labs for today. So what I think we'll go ahead and do now is start the certification. So let's go ahead and talk about it and get you guys rolling on it. So you're going to want to go ahead now and log out of the training account and log back in using your corporate account, your personal account for Sumo Logic. If you don't have one, I would assume everybody should. Actually, not assume everybody should, but if you don't, let us know. We can provide you one, but I'll assume everybody does. And then very simply, you'll just go ahead and log in with those credentials, go to certification, and then choose the level 2 Sumo Power user and take the exam. For this class, there was preparation, which was the webinar and the hands-on labs, which is what we went over. The webinar was me speaking. The hands-on labs was you typing. And then take the exam. It's going to be similar to the first one, 30 questions, multiple choice, 60 minutes, open book, open resource once again. So feel free to use Google, or specifically use the documentation, use the interface, but use Google if you want, however you want to get assistance. Once you're done, you'll pass the exam and you'll get a certificate, and the satisfaction of getting that certificate as well, which is pretty important also. And then we'd encourage you to post that on to LinkedIn and promote it for yourself, promote yourself in that aspect. So go ahead and take the exam. I'll go ahead and basically put ourselves on mute. Certainly if there are any questions, go ahead and put them in the Q&A or the chat and we'll answer them. But otherwise that really concludes today. So let's take the exam. Once we pass it, we'll conclude for the day. And then I hope you can join us next week. Next week we'll be doing level 3, which will be Sumo Power Admin, going over administrative features of Sumo Logic, setting up collectors, password policies, that kind of stuff. And then we'll do the Sumo Security Power user as well, which is similar to what we did today, but it's more security focused. So creating queries that allow you to see when multiple users or a single user is logging in from multiple IPs, things like that. So still using query language, still using things like outlier, but more with a security kind of hat on, if you will. So yeah, let's go ahead and take the exam, and best of luck. And thank you for joining today.